In this videotape, we're going to be going over the basics of working with decimals. A decimal fraction is a fraction whose denominator is some power of 10. For example, 10, 100, 1,000. Let's look at some of them. For example, 7/10 is a decimal fraction because its denominator is a power of 10. A decimal fraction can also be written in decimal form. 7/10 can be written as 0.7. Similarly, 3/100 is another decimal fraction, 3/100, and that can be written in decimal form as 0.03, and it's read 3/100. And 4 divided by 1,000, 4 thousandths can be written in decimal form as 0.004, and it's read 4 thousandths. You can figure out how many decimal digits we would have when we write the decimal fraction in decimal form because it's equal to the number of zeros in the denominator here. 1 0, 2 zeros, 3 zeros. These are decimal fractions, and we're writing them here in the decimal form. Now, all of these fractions had numerators that were less than their denominator. If a decimal fraction has a numerator that's more than its denominator, we would first write it as a corresponding mixed number. 7/10 can be written as 1 and 7/10, and then that can be written as 1 plus 7/10, or 1.7. Similarly, 24/10 can be written as 2 and 4/10, or 2.4. Now, when we want to add or subtract decimals, we have to remember that decimals are really fractions, and the rules for working with fractions will hold. For example, let's say we want to add 0.17 and 0.6, that is 17/100 and 6/10. All right, 17/100 can be written as 17 divided by 100, and 6/10, of course, can be written as 6 divided by 10. However, in order to add fractions, we know that they have to have the same denominator. The lowest common denominator here is 100. This already has a denominator of 100. Here we'd have to use the fundamental principle of fractions to get an equivalent fraction having the denominator of 100. That is, we'd have to multiply numerator and denominator by 10. So we'd have 17/100, and this multiplying top and the bottom by 10 gives us 60/100. 17/100 and 60/100. We add them together. They now have the same denominator. We combine the numerators, and we get 77/100, or 77/100, or 0.77. However, most people don't really change the decimals into fraction form and use the rules for adding fractions. What they do instead, the common rule, is to line up the decimal points when you want to add fractions. So for example, you want to add 0.17 and 0.6. You go 0.17 and 0.6. You line up the decimal points. The decimal point in the answer is directly under these decimal points, and you add zeros where necessary to help you understand what's going on. And adding the 0 here is similar to multiplying top and bottom by 10 over here. So we have 0.17 and 0.60, and we add them, we get 0.77. So this is really the direct way of doing it. You line up the decimal points, adding zeros if necessary, and then add the and add them up, retaining the decimal point in the answer directly under these decimal points. And of course, you get the same answer as if you had changed everything into fractions and added according to the rules of adding fractions. Okay, let's jot down this basic rule, and we will proceed to try some more examples. To add or subtract decimals, line up all the decimal points, add zeros if necessary, and add or subtract in columns, where the decimal point in the answer is directly under the decimal points in what you're adding or subtracting. So line up the decimal points, adding zeros if necessary, and add or subtract in columns. Let's try some examples. Suppose we want to add 3.5 plus 7.8 plus 10.93. That is 3 and 5/10, and 7 and 8/10, and 10 and 93/100. Okay, we will line up the decimal point. So 3.5, under there 7.8, and then 10.93. The decimal points are all lined up. If it makes you feel better, you may add zeros here. However, it's not crucial. It's needed really more in subtraction problems. Immediately put the decimal point in your answer directly under this column of decimal points. And now add in columns. We have 0 plus 0 plus 3, 5 and 8, 13, and 9, that's 22. Put down the 2. Carry the 2, 2 and 3, 5 and 7, 12. Put down the 2, carry the 1, 1 and 1, 2. So 22.23, or 22 and 23/100 for the answer to that problem. Let's try another one. Suppose we want to add 36 and 2.3 and 5 and 17.92. Okay, first of all, if you do not see a decimal point in a number, in other words, if you have an integer, the decimal point is assumed to be directly after the number. So 36 is really 36 point. 5 is really 5 point. Okay, now let's line it up. 36 point, 2.3, 5 point, and 17.92. And if you want to, you could put zeros in here. It helps you to visualize the problem. The answer has the decimal point directly under that column of decimals, and now we add in columns. So 0 plus 0 plus 0 plus 2, 0 plus 3 plus 0 plus 9, that's 12. 1 and 6, 7 and 2, 9 and 5, 14 and 7, 21. 2 and 3, 5 and 1, 6. So 61.22, or 61 and 22/100. Let's try a subtraction problem. Subtract 3.625 minus 2.14. 3 and 625 thousandths minus 2 and 1400ths. Once again, line up the decimal points. 3.625, take away 2.14. Okay, if you want, you can add the 0 here. decimal point in the answer, directly under those decimal points. And now to subtract in columns. 5, take away 0, 5. 12, take away 4, 8. 5, take away 1, 4. 3, take away 2, 1. And of course, you know you can check a subtraction problem by adding. Okay, 5 plus 0, 4 and 8, 12, 1, 4 and 1, 6, 1 and 2, 3. So the answer is 1.485. Okay, let's try another subtraction problem. Subtract 14, take away 6.28. 14 has a decimal point directly after the number. Minus 6.28. Filling in the zeros. 14.00 minus 6.28, and now decimal point in the answer, and we subtract. 10 take away 8 gives us 2. 9 take away 2 gives us 7. 13 take away 6 gives us 7. 7.72. Checking. 8 and 2, that's 10. 2 and 7 and 1, that's 10. 7 and 6 and 1, 14. 7.72 or 7 and 72/100ths for your answer. Okay, let's try another problem. Subtract 2.875 from 13.6. Sometimes the problems are written like this. Just subtract, sometimes with a colon. In other words, this minus that. Sometimes, however, they say it in words. Subtract that from that, in which case you have to rewrite the problem as 13.6 minus 2.875, lining up the decimal points. Subtract this from that. Filling in the zeros, putting the decimal point into the answer, and getting 10 take away 5 is 5. 9 take away 7 is 2. 15 take away 8 is 7. And 12 take away 2, 10. So 10.725, or 10 and 725 thousandths. Let's try now a word problem involving decimals. One day, John spent $58.42 on books, $25.10 on clothes, $3.75 for lunch. How much money did he have left? If he started the day with $100. Think about that for a moment. Okay, I said this was an example involving decimals. Problems involving dollars and cents are really problems involving decimals. They're usually the first decimals that you work with. Okay, he's buying books, clothes, and lunch, and he starts off with $100. Let's first figure out how much he spends. He spends $58.42 plus $25.10 and $3.75. So this is an addition problem involving decimals. Putting the decimal point in the answer, we're going to get how much he spends. So that's 2 plus 5, 7, 4 plus 1, 5, and 7, 12, 1 and 8, 9 and 5, 14 and 3, 17, 1 and 5, 6 and 2, 8. He has spent $87.27. But that was not the question. The question is, how much money does he have left if he starts the day with $100? So he will have left, it will be $100 minus what he spent, $87.27. Remembering that with an integer, the decimal point follows the number. Putting in the zeros, we now do our subtraction problem to find out how much money he will have left at the end of the day. 10 take away 7 gives us 3. 9 take away 2 gives us 7. 10 take away 7 is 3. 9 take away 2 gives us 7. 9 take away 7 gives us 2. And 9 take away 8 gives us 1. So $12.73 will be remaining at the end of the day. Checking, 3 and 7, 10, 2, 7 and 1, 10, 2, 7 and 1, 10, 1, 1 and 8, 10. Okay, so we basically understand how to add and subtract decimals. We're going to line up the decimal points and add and subtract in columns, adding zeros if necessary. Now let's discuss multiplication and division of decimals. Let's start with multiplication. Let's say we want to multiply two decimals, 0.3 times 0.42. Once again, the way to figure out how to work with decimals is to realize that they're really fractions. This is really 3/10 times 42 100ths. 3/10 times 42 hundredths. Now, while you have to have the same denominator to add or subtract fractions, you do not have to have the same denominator to multiply them. In fact, what you do is you multiply the numerators and divide by the product of the denominators. Well, 3 times 42 will give us 126. 10 times 100 will give us 1,000. So we have 126 over 1,000, and that is a decimal fraction which can be written in decimal form as 0.126, 126 thousandths. Using this idea, we can develop a rule for multiplying decimals. What we do is we figure out the number of decimal digits in each of the factors. That is, a number of digits to the right of the decimal point. This factor had 1 decimal digit. This factor has 2 decimal digits. We add them up, 1 plus 2, and the answer has to have 3 decimal digits. Okay, and we can see the logic for that. 0.3 will have 1 0 in the denominator. 0.42 will have 2 zeros in the denominator. When we multiply, we will wind up with 3 zeros in the denominator, which corresponds to the number of decimal digits. The number of zeros here corresponding to the number of decimal digits. Okay, so let's write down our rule for multiplying decimals and try some more examples. To multiply decimals, multiply as integers the numbers, count the number of decimal digits in each factor and add them up. This total, whereas you're adding them up over here, this total will be the number of decimal digits in the answer. So we're going to multiply the numbers as integers, count the number of decimal digits in each factor, add them up, and this total will be the number of decimal digits in the final answer. Going back to the problem we had just done, 0.3 times 0.42. In other words, you would multiply just 42 times 3 and get 126. You just multiply as if they were integers and then say this has 2 decimal digits, this has 1 decimal digit, 2 plus 1, this should have 3 decimal digits. Okay, let's try another example. 0.3 times 0.15. You simply multiply as if they were integers. 3 times 15 would be 45. And say that this has 1 decimal digit, this has 2 decimal digits, 1 plus 2, 3 decimal digits in the answer, so it has to be 0.045, or 45 thousandths. It has to have 3 in the answer. So we had to put a 0 in to hold that place here. Okay, let's say it was 17 times 0.23, or times 23 hundredths. You simply multiply as if they were integers. 3 times 7, 21. 1 times 3 and 2, 5, so it's 51 there. 2 times 7, 14. 1 times 2, 2 and 1, 3. That's 391. And now there are no, 17 is really 17 point. The number of decimal digits is the number of digits to the right of the decimal point. There are none here. There are 2 here. 0 plus 2, so there'll be 2 in the answer. So the answer is 3.91, or 3 and 91 hundredths. Let's try a word problem now for multiplying decimals. If super unleaded gas costs $1.24 per gallon, how much will 18 gallons cost? This, of course, indicates multiplication. To figure out the cost of 18 gallons, you will take the cost for 1 gallon and multiply by 18. 18 is really 18 point. 4 times 8, 32. 2 times 8, 16, and 3, 19. 1 times 8, 8 and 1, 9. 1 times 4, 1 times 2, 1 times 1, 2, 4 and 9, 13. 1, 9 and 2, 12. 1 and 1, 2. 2 decimal digits, no decimal digits, 2 decimal digits in the answer. So $22.32. Okay, let's now figure out how to divide decimals. First of all, to divide a decimal by a whole number, or to divide 2 whole numbers. we will follow the following rules. 1, we will put the decimal point in the quotient directly above the decimal point in the dividend. I'll explain this with an example in a moment. Divide as you normally do. And use zeros if necessary to keep the decimal point in the right place. So to divide a decimal by a whole number, or to divide two whole numbers, we will do the following. We'll put the decimal point in the quotient directly above the decimal point in the dividend, divide as you normally do. It's basically just a matter of placing the decimal point, similar to the multiplication problem, just figuring out the right place for the decimal point, and adding zeros if necessary. You'll see some examples that'll make sense. Suppose we have 3.75 divided by 5. That is a decimal divided by a whole number. This can also be written as 3.75 over 5. Now you have to understand that these mean the same thing. This line in the fraction is really divided by 3.75 divided by 5. Either way, you could write that. Now, 3.75 is known as the dividend, and 5 is known as the divisor. And the answer you get is called the quotient. Well, according to the rule, we're going to put the decimal point in the quotient directly above the decimal point in the dividend. And now, basically, you can ignore the decimals and just divide as you would normally do. How many 5s in 3? Doesn't go. 5s in 37. 5 times 7 is 35. Subtract 2, bring down the next place, 5. 5s in 25 goes 5 times, for an answer of 0.75. Now, in any division problem, you can always check your answer by multiplication. For example, 12 divided by 3 is 4. 12 divided by 3 is 4. This is checked because 3 times 4 is 12. Similarly, to check this, 0.75 can be multiplied by 5 to get 5 times 5, 25, 5 times 7, 35, and 2, 375. 2 decimal digits, no decimal digits, so 2 decimal digits. So it works out. Okay, remember here, however, we were dividing by a whole number. That's the key. Here the numerator was a decimal. However, it can also be done where the numerator is a whole number as well. 3 divided by 4, or 3/4, okay, would mean 3 divided by 4. Now, we're to put the decimal point in the quotient directly above the decimal point in the dividend. Well, you may say there is no decimal point in the dividend, but if it's an integer, the decimal point follows the number. So the decimal point goes there. We will add zeros here to help us, and now we go 4 into 3. Now 4 into 30 goes 7 times 28. Subtract 2, bring down the 0. 4 into 20 goes 5 times. And we get 4 times 5, 20. So we have 0.75 for the answer here as well. Let's try another example. Suppose it was 0.375 divided by 5. It has to be 5 into 0.375. Put the decimal point there, directly over the place in the dividend. 5 into 3 goes 0. 5 into 37, 7. 5 times 7 is 35. Subtracting 5 into 25 goes 5 times. Here the 0 is crucial to get the right place in the answer. So 0.075 or 75 thousandths for your answer. And of course, it's just a coincidence that all the answers came out with 7s and 5s. Now, we've mastered dividing a decimal by a whole number or dividing two whole numbers. Suppose we want to divide a decimal by a decimal. Okay? Let's write down the rule. To divide a decimal by a decimal. First of all, write the problem as a fraction. And then in that fraction, multiply the numerator and the denominator by the appropriate power of 10. So that the divisor is a whole number, then proceed as before. In other words, the whole key is that you must have the divisor as a whole number. Without that, you can't work. The divisor has to be a whole number. Once the divisor is a whole number, you're dividing by a whole number, it reverts back to the last set of rules. Okay, for example, let's say we have 86.4. By the way, if you're not finished copying these rules, you can, of course, pause the machine and then copy them. Okay, let's say we have 86.4 divided by 0.36. One decimal divided by another. Rewrite this in fractional form, 86.4 divided by 0.36. Now we want to multiply top and bottom, numerator and denominator of this fraction by an appropriate power of 10 so that the divisor will become a whole number. 0.36 has to be multiplied by 100 to move the decimal point 2 places to the right and turn this into an integer. If you multiply the denominator by 100, you have to multiply the numerator by 100 as well. So we're going to move the denominator's decimal point 2 places to the right because we're multiplying by 100. That gives us 36 point. And here we move the numerator's decimal point also 2 places to the right, giving us 8,640 with a point. So now it turns into dividing whole numbers, which we know how to do. This will be 36 into 8,640. With a decimal point following the number. And 36 into 86 goes twice, giving us 72, 144, no, subtracting and bringing down the 4. 36 into 144 goes 4 times. 4 times 36 is 144. Subtract. Bring down the 0. 36 into 0 goes 0 times. You must put the 0 in here, however, to keep the place right. 24 would be incorrect. It's 240. And then you can stop because from now on it's all going to be zeros. So 36 goes into 8,640 240 times. Some people have the habit of immediately going and saying this is 0.36 into 86.4 and saying I have to move this to make it a whole number 2 places to the right, and I'm going to move this also now 2 places to the right. That's fine, as long as you understand that what we're really doing was using the fundamental principle of fractions. That is multiplying the numerator and denominator by 100. That is shifting the decimal point in the numerator and the denominator, in this case 2 places to the right, so that the denominator here becomes an integer, and then you can divide as you would divide integers. Okay, so this procedure is fine. This is just the reason we're doing it. Let's try some more examples. Say we have 36 divided by 0.4. This will be 36 point divided by 0.4. 36 had no decimal point, so we placed it right after the number. We will multiply numerator and denominator by 10, so that the denominator is now an integer. 0.4 times 10, move the decimal point 1 place to the right. That gives us 4. And here, 36 times 10 is, of course, 360. So now it's 360 divided by 4, putting the decimal point right over the decimal point in the dividend. 4 into 36 goes 9 times 4 into 0 goes 0. The answer is, of course, 90. Let's say this was 0.36 divided by 0.9. 36 hundredths divided by 9 tenths. This is 0.36, remember, it's a fraction, divided by 0.9. We have to multiply numerator and denominator by 10. That is, shift the decimal point in the numerator and denominator once to the right. This will give us in the denominator 9 point. The numerator will become 3.6. So this is 9 into 3.6. Decimal point over that in the answer, and 9 into 36 goes 4 times. So the answer here is 0.4 or 4 tenths. And of course you can check 9 times 0.4 would be 36 with 0 plus 1, 1 decimal digit. Let's finish off this tape with one word problem. A woman pulls into a gas station. I do seem to be preoccupied with gasoline today. I must need gas. Okay. A woman pulls into a gas station and asks to have her car filled with regular gas. She sees that this type of gas, this gas costs 98 cents per gallon. If she pays $12.25 for the gas, how many gallons did she get? Now, most of you are saying this must be a division problem because it comes after I taught you how to divide decimals. But hopefully you see why it's a division problem. We know the cost per gallon. We know how much she pays. If we divide the total amount she pays by the cost per gallon, we'll learn how many gallons she buys. So we want to figure out what is $12.25 divided by 98 cents. How many times does 98 cents go into $12.25? That'll tell us how many gallons. So this is 12.25 divided by 0.98. We will multiply numerator and denominator by 100 because we want to shift the decimal point 2 places to the right. So this will give us 1,225 divided by 98. Okay, that's 98 into 1,225. The decimal point in the answer will be directly over the decimal point in the dividend, and here it follows the integer. Okay, how many times does 98 go into 122? That's once. We get 98, and we subtract. 12 take away 8 is 4. 11 take away 9, that's 2. Bring down the 5. How many times does 98 go into 245? That's twice. 2 times 98, 2 times 8 is 16. 2 times 9, 18, and what's 19? Subtract. 15 take away 6, that's 9. 13 take away 9, that's 4. Now, bring down the 0. How many times does 98 go into 490? Trying 5. 5 times 8 is 40. 9 times 5, 45, and 4 is 49. So it goes evenly at 12.5. So the answer is she got 12.5 gallons of the regular gas. And that brings us to the end of this tape.